Alright, so I believe we're back. Hello, hello. Gonna take a look at the next question here, next medium question on LeetCode. Welcome, welcome. And yeah, I think we can get right into it. So we'll do that. So howdy, howdy. Design snake game. Let's see, how do we do here? Design a snake game that is played on a device with screen size height X by width. Whoops, whoa. Play the game online if you're not familiar with the game. Did not mean to do that. Snake game, play the game online if you're not familiar. So, design a snake game that is played on a device with screen size height X by height by width. Okay. And play the game online if you're not familiar with the game. The snake is initially positioned at the top left corner with a length of 1 unit. You are given an array food, where food of I equals R of I, C of I, is the row and column position of a piece of food that the snake can eat. When a snake eats a piece of food, its length and the game's score both increase by 1. Each piece of food appears one by one on the screen, meaning the second piece of food will not appear until the snake eats the first piece of food. When a piece of food appears on the screen, it is guaranteed that it will not appear on a block occupied by the snake. The game is over if the snake goes out of bounds, hits a wall, or if its head occupies a space that its body occupies after moving, i.e. a snake of length 4 cannot run into itself. Okay. So if you go out of bounds or you hit yourself, basically if the snake hits itself, the head occupies a space that its body occupies after moving. Right, so this is saying the snake of length 4 can't run into itself. Got it. Implement the snake game class. Snake game int width height int food initializes the object with a screen of size height by width and the position of the food. Int move string direction returns the score of the game after applying one direction move by the snake. The game is over, return -1. Returns the score of the game after applying one direction move by the snake. If the game is over, return -1. Okay, interesting. So actually designing snake isn't really that hard if you think about it. The tricky thing really is just the visual part. The programming is probably not that difficult. You have this logic that I'm about to implement here, and then all you've got to have is a game loop that every few seconds, basically, whichever key the user presses between each sort of move interval, that just sets the direction that he's going to move, and then you actually apply the move logic and just update the screen with the results of the move. That's it. It's actually probably a pretty relatively easy game to program. Neat. Neat. Yeah. The trickiest part, the hardest part, is probably just the visual part. You know, getting the, setting up a screen to actually, has the graphical part of it, I guess. So, interesting. So we have a width and a height. We have this food. We have food length. What does... Excuse me. Oh, there's 50 pieces of food. Okay, I get it. Food of I length, right? So food of I is this vector is basically a pair of integers, the width and the height. Direction length is 1. What is direction? Okay, direction is a character of up, down, right, left, right? One of these 4 characters. And most 10 to the 4th calls will be made to move. Interesting. And what does this return? the move. Score of the game, if the game is over, return -1. Okay. Huh. All right, pretty neat. Pretty interesting question. So, yeah, glad we're taking a look. So let's see. We have if it bites its body or if it crosses the boundary. And if it grabs the food. Okay. So we can do like a few things. We can use a food iterator here. And what happens when the game is over? If you get all the food, what are you supposed to return if you get all the food? I guess you just keep returning the score. I guess it doesn't matter. It just keep returning the score on each move until either there's no more moves or yeah, you could do it that way. Okay. Let me see. So there are a couple things here. So we want to map the direction to probably a delta values for like the direction. So up, down, left, right would be sort of a set of pair of values, map it to a pair of values, which would give you the difference in the row and column position of the snake head. And we actually do want to maintain what's interesting here is we probably want to maintain the snake itself, and we want to know. The trickiest thing about this probably is actually going to be just maintaining the body, whether or not the head runs into the body. Again, we want to be clever about that, do that as efficiently as we can. So we have the head position, and then what we can do is actually put the snake's positions into an unordered set, and we can actually do a couple things. So we can, we could put the snake's positions into a queue and also maintain the snake's positions in an unordered set. And then when we pop the queue, that's the tail, really. As we push more things onto the queue, we increase the body of the snake, and when you move, what happens is you move the head. Oh man, this is pretty interesting. So we also have to figure out when we get the food, what we're gonna do. Do we have an initial length? I think each time you get food increases the length of the snake. So how do we increase the length of the snake, though, is the next question. Like there are some questions here. I guess they have pictures. So if we don't consider the food for a moment, we just have a fixed length. Suppose we have a fixed length, then actually each time you move, you only pop the back part of the queue because the snake moves towards where it was, right? So you only have to pop the back element off of the queue for the snake, and then you add where the head is to the snake. So wherever the head is. So it's actually maintaining where the snake is relatively easy. It's relatively efficient, right? It's only the back and the head that are really moving at each and then sort of all the stuff in between are just kind of hanging out there. So you would push and add to the set when you move, and then also pop and remove from the set when you move. The back you remove and pop, and the head you add and insert. Everything else is basically the same as you go. So it's constant time to move the snake. Now when you increase the size of the snake, and then you can also use that in constant time to check whether or not the head, after you've moved, so you move first, recalculate everything, and then check if the head is in this before you add the head to the set is what you want to do. So you would remove the tail, and then check if the head is in the set, and then you would add the head if it's not. If it's in the set, then you died. If it's not in the set, then you can add the head, add it into the set, and add it into the queue. And the queue lets you know which ones to remove. So you can use a queue and an unordered set to maintain to move the snake. Efficiently, right? To efficiently maintain the movements of the position of the snake. So now what you want to do is you also obviously the boundary too. You do a boundary check as well for the head. And so those are the conditions when you fail. For failure, we want. By the way, you don't need to get a copy. You don't need to copy the string. We're going to have a few things here. When you eat the food, that's the next thing that we're kind of hung up on a little bit here. When you eat the food, you increase the length. So the question is, when you eat food, what happens to the length? I don't have a picture of it. Because the length is supposed to increase. How does it increase when you eat the food? So right, down, right. Okay, it looks like when you eat the food, the head, where the head was, or rather, basically you don't remove the tail. That in that instance, right? That's pretty much if you're on a food portion, you won't remove the tail. That's how it's going to increase length. Okay, yeah, we can do it that way. That's fine. So yeah, okay, we can do these things this way. So we have a few different things to consider. We want HW to be the height and width, and we're going to use that for our bounds checks. We're going to have a unordered set for the of we're going to use pairs for things here. I believe you can hash pairs of integers in C++. I'm actually not sure. Snake position. Let's say, can we, does this compile? Let me see something here. Whoops. No. Implicitly deleted. Wait, what? Wait, what? Okay. Yeah, I was wondering. I think this causes problems. I don't know if you can actually do this. Implicitly deleted default constructor. Can you use tuples? Yeah, that's kind of what I was getting at. Right. Can you not use an unordered set for pairs or tuples? There's got to be a way to do this. Boost has hashes. There's no standard way of computing a hash on a pair of this definition to your file. You can use it like this, pair hash. Pair 2122 defines equality. Provide a way to test equality. You may need to provide a separate function to test the two instances are equal to each other. Limited to a pair of two integers. LeetCode helps you more generally with hash multiple objects. Why does this work though? Times 31 plus the other one. Couldn't you run into issues where, like, let's say these are multiples of 31, they could end up being, you could end up with two things that are equal to each other, the hash. If you do, I guess you gotta define your own hash operator. But the problem with that is like, there are a few different problems with this, right? Like, first things first, this could end up being a very large, this could overflow. What standard size T do? Okay, this can store the maximum size of theoretically possible object of any type, whose size cannot be represented, is ill-formed. Many platforms, an exception is systems with segmented addressing can safely store the value of any non-member pointer, in which case it is synonymous with standard U and pointer T. It's commonly used for array indexing and loop counting. Programs that use other types, such as unsigned int for array indexing, may fail. 64-bit systems when the index exceeds or relies on 32-bit modular arithmetic. Indexing C++ containers such as string, vector, etc. The appropriate type is the member type def size type provided by such containers. It is usually defined as a synonym for standard size T. Okay, I see. Okay, understood. So size T could be gigantic. Okay, I understand. I've seen this before, but I kind of never really understood it. So size T is gigantic. potentially gigantic. It's the unsigned integer type of the result of the size of operator, as well as the size of operator and the align of operator. The bit width of size t is not less than 16. Gotcha. So you want to use size t. Okay, understood. Well, but the question is, all right, so it won't overflow if you use size t. Then the question is, what are these, what is this hash? Like if you had, you definitely could have pairs that hash the same value if you do this. Just multiplying by some prime number doesn't really help you that much. So yeah. What is this? What is this hash, man? Where did that come from? What? I mean, you could bit shift this integer to the left and calculate a much larger integer. You could do it that way. So if these are both 32 bits, and you just bit shift this all the way to the left and basically use 64 bits, you could do it that way. That possibly could work. That would be sort of a perfect hash. I don't know how efficient it would be. I don't know how good it would be, but it would work at least. I wonder if it would work. I kind of want to try that. So that would be one way of doing an unordered set of integers at least. Use a pair hash. How about, well, we could try that. I don't know if I want to try that. Alternatively, you could just use a, what do they call that? A regular set and use logarithmic time comparisons. Hash pair operator, standard hash int hasher, XOR the hasher with another hasher. Move to chat. Andy Prowl's answer, also add to the standard namespace beside, it's not illegal, just undefined. GCC, it always works fine. You can create a new namespace if you want. Specialization. Bad example of computing hash, rather replace with something more clever. Won't give you problems anymore. Why do they keep doing this? I don't really like this 31. It seems so, it doesn't seem good. You know, if you have like 1 and 31, and then you have that'll get hashed to 62. And then if you do something else that gets you 62, 2 and 0, those get hashed to the same spots. Oh, I guess it doesn't matter if they collide, or I guess it doesn't matter if they collide, because you'd have, what do they call that? You have, like, the unordered set handles collisions reasonably well, I guess. So I guess it doesn't really matter. You can just multiply it by some relatively large prime number. Four bytes, 8 bytes. Oh yeah, this is what I was thinking of. Yeah, the or the or addition both work here. Yeah. So now you can make it unique. String separator. Use a stringify. No, don't do that. That's so expensive if you do it that way. Bad hash. Some of these seem okay. This seems like one of the better ones. Although I'd rather just define a lambda, and then you could use the hash function itself, the built-in, and then XOR the hash function. Get something generally pretty good, I guess. How does that even work? Two integers cannot be combined into one integer in a unique way, so hash cannot possibly be unique. Oh, I see. So it doesn't matter if it's particularly good. Spelled that wrong. Essential understand limitations. C++ place some mathematical computations. Its value is guaranteed to be 0 for any I above. Okay, but why are they arguing with each other like this? You claim derp derp derp. I'm so annoyed, man. I'm looking for answers. I appreciate the mods putting this in the chat, because I was like, I need to know, like, what's the deal with these hash functions? They could have been, you know, this reminds me of. This reminds me of me. Like, I'm supposed to be a Christian, right? I'm supposed to be graceful. I'm supposed to be gracious, and basically, like, you could tell they're getting catty with each other, right? That's how it comes off, right? And like, I'm no better. Like, I would do that. I would do that in a heartbeat. I do the same thing, and I would do the same thing. Arguing with other people over things. But I guess what I'm called to do is be more gracious, and like, basically you would explain like what I'm missing, because I had the same question. What I'm missing is that apparently what I've assumed, I've realized as I'm kind of going through this, is that even though the hash function isn't perfect, it's not a perfect hashing, it doesn't matter because it's not supposed to be perfect hashing. You're supposed to, with the hash tables and whatnot, you expect to have collisions, and so the STL would already have some way of handling the collisions internally. The hash function just needs to be good enough to guarantee certain bounds, certain use cases. So the use cases, relatively what do they call that? Is I guess consistent, sort of. The expected usage is reasonable, and also with collisions, like there will be collisions. So what's missing here is just a simple explanation that your hash function will have collisions, and that the STL handles that reasonably. And that's it. That's all he has to say, this fellow. But they're kind of like nipping at each other with different, what do they call that? Different points that are kind of irrelevant and meaningless. Like really, all you need to say right here, which is what I would want to say, is, hey guys, hash functions have collisions, so it doesn't need to be a perfect hash. The underlying data structure is designed to handle collisions. So you just need to have a good enough, quote unquote, good enough hash function. And that's it. That's all that has to be said here. But here you have this like long thread back and forth of 14 days later, frozen for an activity. It's like, oh boy. But yeah, so let's see. Oh, let's go through this slowly. What are stars here? What does that do? Something about Fermat's theorem to compute the modular result. Points moot. C++ integers, not math ones. Clear anyone reading the answer, you can't make a mistake. Do mathematically has nothing to do with the question. Do C++, you take 32 mega hash function, generate a unique key for that pair. Explain how as well. Is that true? I don't know if that's true. Theoretically impossible to squeeze information from two integers into a single integer of the same size without a loss. Hence you that suggests that you code up an algorithm for computing unique hash the way that you think is going to work for 16-bit integers. Put id1.com and I'll give you two distinct pairs of integers that yield the same result. Oh yeah, well there you go. Yeah, right, true. True. And no. I think what he said is, I think what this fellow said is right. I don't think this McCogan guy, he's kind of coming up with a bunch of stuff. I don't think it'll actually work in practice. Although it's interesting to see if he could, but I don't think he can. So what I wanted to say is, I wanted to see how old is this post. This is years ago. Okay, interesting. Represent the number of two ints, one being the base, the other being the exponent. Now you have a key is mathematically unique. If you also know that I and j, yeah, but that key is way beyond the bounds of. First off, that's not true actually, because you can have. Is that true? If it's not it might be true. No, it could be. If they're not the same integer, then I think it is unique because you have. I actually think you can get the same number if you're not using prime numbers. You can actually swap A and B. A raised to the B equal B raised to the A. Is that possible? If they're equal, it's possible. But if they're not equal, log B of A equals A log b. But this won't fit in, you know, given any arbitrary 32-bit integer. This certainly won't fit. If you take a modulo operator, like that's not unique modulo, right? The modulo operator squeezes all of that. Yeah, so that's not really true. But then you have, I don't know, a equals a over natural log a is equal to b over natural log b. Is that right? Divide by natural log b, divide by natural log a, and then I don't know, we exponentiate both of these to e. That gives you it's actually it's e the natural log of a raised to the a. Is that right? No, it's not right. I want to say it's something like e raised to negative natural log of a. That's so confusing. I don't know. What? It's actually it's this root of natural log of a of e raised to the a. If you do e raised to the if e squared e squared raised to the third is equal to e to the squared times e squared, which is e 2 plus 2 plus 2, which is e of 2 times 3. Yeah, okay, correct. So, but this is a little weird because e raised to the 1 over log of a, natural log of a. Which this is natural log of a raised to the negative first power. Which is something like which is not the same thing as negative natural log of a. Because that would make things a lot easier here. That would make things a lot easier if this was what I thought was the truth. I want to reduce this to something simpler if I can. Also, this is B, not A. It's not. I'm not getting there though. How do we get from snake game to hash to natural logarithms? Hash functions. Hash functions. Yeah. So, what if you have e raised to 2 squared, right? That's not the same thing as e squared squared, because that would be e of 2 times 2, not e exponentiated. So we can't do, what I'd like to do is do something kind of clever with 1 over the natural log of a. However, it's looking like we can't do that. No. No. What's interesting about this is we know that these are both. We can go back here. However, somehow I want to show that A has to be equal to B is the only solution for this. That's kind of what I'm getting at here. Natural log of 1, I think, is 0, right? Yeah. So this doesn't make a lot of sense anyway. This probably shouldn't mess around with this anyway. These two. What you can do, however, is you can go the other way around. You could say natural log of A over A equals natural log of B over B. And then you get E raised to these things. So A raised to 1 over A equals B raised to 1 over B. That you can go there because you can do E raised to these two things. And then that's now E raised to the natural log of A times the whole thing raised to 1 over A. Right? So A raised to 1 over A equals B raised to 1 over B. And I don't know how this helps us, though. I don't know what this really does for us. Like, okay. Anyway, whatever. It doesn't matter. I don't think we need to go that far with this. Basically, the point is, I think what this fellow is saying is correct. This key is not unique. It's unique. It's unique if you expand beyond the number of bits you're bounded to, but that doesn't work like that, right? This is really disingenuous. What he's saying is correct, but the range of numbers matters a lot. Like, we're not dealing with 7-bit precision, we're dealing with 32-bit, and then we're dealing unless the hash that you're hashing it to has more precision than has more bits. That's his whole point, right? Like, his whole point is that if you have 64 bits worth of information, you're going to have potential loss if you try to cram it into less than 64 bits. Like, that's pretty much it. It's not really. Yeah, this is what he's saying, is that if you do the modular arithmetic, it's not going to be unique anymore. Right, which is what he said. But anyway, what is... Yeah, like, this is just kind of back and forth. I don't know why. The point the point should be, and this is right, the graciousness, right? It's like, how can I be more gracious in this instance, right? I guess the question I should ask myself is that I think that they're not understanding each other here. They're both saying correct things, but both of those things are not relevant. Like, neither of what they're saying is relevant. That's why I was annoyed, because, like I said, the answer is that hash functions have collisions. They're expected to have collisions. So your hash function doesn't need to be perfect. That's it. Done. Moving on. And then here I am trying to figure out, wait, is A raised to B equal to B raised to A always uniquely defined a pair of integers? I think that it does. It might be true. I thought maybe it couldn't, but I'd have to find an example. unless A and B are equal. Obviously, if A and B are equal, it's irrelevant. But if they're different, can you get a number that has two exponentiations, two representations? I don't think you can, and the reason is because you have the prime number, or no, I guess the prime factorization theorem, that every number is factorized into uniquely into prime numbers, into multiples of prime numbers, and so any a raised to the b is going to give you some, the prime factorization of a, and then like you multiply all of those values by b. And so what you would need to do is you need to have some a and b such that basically have the same prime numbers, so they're multiples of each other, a and b. And then also the exact amount that you multiply one of these, but yeah, maybe if they're multiples of each other, it could work, right? So like if you have, I think you can. I couldn't do it algebraically, but I think you can show it like, so a is some, some p sub I, right? Some product p sub I raised to the alpha I, and then b is just some constant, whatever it is, I don't know. And let's say b is some constant, some multiple times a, right? P of I, a of I. We'll do beta of I. Do it that way. Oh no. Yeah, a of I. Yeah, because it's not just a constant. It's like, it's got to be basically. Let's do it like this. Let's do. It's k of beta I of alpha I, where k of alpha I equals beta of I. Something like this, right? And then when you do a raised to the b, it's going to be this guy, p of I alpha I. It's actually raised this power, so you're multiplied by b at each instance, right? Yeah. And then b raised to the a is b of I beta I times a. You have to have alpha I times b equals beta I times a for all I. And I don't know. I mean, maybe you could. Maybe a over b gives you alpha of I over beta of I, which is some constant k. Yeah, that's what I was saying. That's what I was thinking. I was like, if they're a constant multiple of each other, some constant multiple, and they're not prime numbers, or even if they are prime numbers, like 5 to the, let's say 2 to the 4th, and 4 squared. Aha! Aha! I'm a genius. I'm a genius. Now, I guess what he was suggesting though was a 2 raised to the I and 3 raised to the J, where these are powers of numbers. That's a little bit different. But yeah. No. Aha! There you go. I figured it out. All right. I was like, I'm pretty sure these could be. They just need to be. Now I don't know algebraically before I wasn't able to show that these are these are just have to be multiples of each other. The reason why I couldn't show that is I don't know. What was the issue that I ran into? Yeah, I was gonna say, I was like, I don't think that's correct. They're using the base and the exponent for the numbers. It doesn't. That's not a unique key. Actually, yeah. I don't know, the algebra that I was doing, I wasn't really able to show that, but that's somehow it's, you can see it, that if they're, one example at least is 2 to the 4th 4 squared. All right, done. All right, that was what I was trying to do. I was like, wait a minute, I'm pretty sure you can show this. Anyway, no real point to any of that. I mean, this is kind of a waste of time, sort of, all of this. I suppose you could use the int hasher to define a hash. We could do it that way. Let's do it that way. I like that one. I like that one. Just XOR of int hashes. All right. So really not that important. Really not that important. We can do pair hash. And we're just going to go ahead and make this. How does this work? It's a struct. Can I do a private struct pair hash, which uses const bool. No. How did they do this? Hold on. It's another way to hash things. Oh, that's interesting. More general. I just wanted the pair hash. Okay, inline size t operator const. Okay, I just want to know if you have to put const over here. You don't really need to. Okay. And did it wait a sec, did it return void? Did I say? No. It doesn't need to be void. It could be whatever, it doesn't really matter. It could be size t. We're gonna use an integer for this one. So or yeah, we're gonna try that. So we'll do int operator, I wanna say, right? Oops. Yeah, it's this operator. Okay, that's interesting. Sure. These don't really need to be constants here. Could just be A and B. It really doesn't matter. Well, I don't know, I guess it's kind of good practice to not modify the integers. I don't know, just do it to A and B, whatever. What do they do? What do they do? I gotta know. Oh, no, you do a pair. Okay, my mistake. Got it, understood. Understood. Okay. Yeah, something like this should be fine. Question though is is this okay? Okay, neat. So now we want Yeah, so we were able to do that. So does this work? Or do we need to put this after? Okay, cool. All right. Anyway, this isn't really like, this is just kind of an aside, because I've run across this problem a few times where I'm like trying to hash, what do they call that? Trying to hash. Oh, actually, this isn't bad at all. I could have done. No, never mind. Anyway. Hold on a second. Just thinking. Actually, if I use the width of the, what do you call that? If I use the width of the height and the width of the board, or we're going to do n rows and columns for the height and width rather. It's a little bit easier to think about. The number of rows is the height and the number of columns is the width. And if you use the number of columns and you multiply the number of columns times the first value and then add the second value, right? That gives you sort of the row column pair. That actually would be a unique hash within this sort of game universe, because it's basically a two-dimensional array mapped to a one-dimensional array, where each row is sort of the next chunk of the array. So actually, there is a hash function. Like this is more general, but there's a hash function for this particular instance that's sort of perfect hash that exists for our expected use case. But anyway, that's neither here nor there. Let's see. Okay, so this does compile, which is kind of neat. All right, cool, nice. All right, anyway, that's like almost completely unrelated to anything. Like we almost don't care at all about this, but we do we do want to snake body and then snake. Okay. Yeah, we do want to, what do you call that? We do want to use an unordered set to give us expected constant time operations, and then also use it as a queue. So anyway, so excuse me. So the thing we're trying to do is we're gonna get a number of columns, number of rows, so width, height. There's a few different pieces we want to look at. We want to set up the directions as well. So we'll have, it's going to be an unordered map of characters to also to pairs, and this is going to be the directions. And we're going to set that up when we create our initializer list. And we're going to have 4 pairs. It's going to be, so it's row column. We're going to say north, east, south, west. And actually, there's 2 pairs. It's a pair to pairs, right? There's a couple things here. So it's a pair to pair. So this pair is going to be up, and we're going to go to decrement our column, our row, and increment our, and not touch our column. So up, we have right, we have down, we have right, yeah, we have right. We'll do it this way. So we'll say up, right, down, and left are going to be mapped to up. Right is this one, down is this one, and to the left is this one. Right, in terms of modifying the row and column positions. So let's see if this compiles. It does. Awesome. Sweet. So here we get our directions using initializer list. And now we have number of columns, number of rows, directions. We could say, I want to like define our inbounds check here. Okay, what else do we need? So we have, and the food also, we want a food counter, food pointer. So standard, it's this guy. I'm not going to modify this at all. We're going to say vector of integers, const iterator, and it's going to be current and end. These two, yes. And we're going to use that to walk through food. So current food, end food. Okay, and can use that later. What else do we need here? So it feels kind of disorganized. Like I have a very clear idea of each piece, but it does feel very disorganized how I'm kind of approaching this. So now these are actually strings. These aren't characters. Because we're going to use a string, not a character. So we'll make these strings then. That's fine. You know, whatever, not a big deal. So it's U, R, D, and up, right, down, left. Okay. So now we want to say the way the snake's going to move, we have an inbounds check. Inbounds. And that does the following check. We have int row, int column, say return rows greater than or equal to 0, columns greater than or equal to 0, and rows less than number of rows, and columns less than number of columns. All right, real simple inbounds check that you always got to do. And then let's say auto hit body, same thing, or similar thing. It's going to be row and column. We'll say snake body. Return snake body dot count of standard make pair of row column. That's if we hit the body, right? So it's after we move though, right? That's what we want to. Yeah. So we don't need to. We can just comment that out basically. We don't need to. Yeah, we can leave that. These can kind of be inlined. I don't know if you can inline. Can you inline lambdas? Yeah, I'd like to be able to do that. That'd be nice. Okay, compiler would probably do a better job anyway. Nice. Nice. That's good to know. Okay. Good to know. So we're still live, right? I see some drop frames. Okay. Anyway, so there are a few things here to consider the logic. So the head, when you increase the length, when you get the food, you don't remove the tail. And what else are we looking for here? Let me just think. The way you move the head. Well, okay, let's do this. Let's calculate the next position. So we'll say int next row and next column. So we're gonna say take this direction. Take this directions of direction. We're gonna say const auto dr dc dcolumn d row dcolumn. We're going to say next row equals sort of the head and the row column. Initially those are set to 0. So the initial positions. Row plus dr. Next column is column plus dc, right? So now we have our next position. We say if not in bounds of next row, next column, then return -1. Otherwise we say const auto foodr food c equals, so if current food not equal to end food, we have this check for the food. Calculate next position. And end the game out of bounds. Check for eaten food. Eat. False. So if we're not at the end, if we haven't eaten all of the food yet, food RF is going to be current food dereferenced plus current food. Or no, not necessarily. We say if next row equals food R and next column equals food C. We'll set 8 food equals true. Now we have a score as well. I think you could initialize these as 0 without a problem. I think you're allowed to do that. You just return. Just want to see if this will compile what we have going on here. Oh yeah, this is I forgot. Okay, this doesn't dereference this way. That compiles, nice. And so for inbounds, we want to see we ate the food. Check for eaten food. We want to, yeah, we just want to check if it compiles first right now. If we ate the food, we do some things. Oh, there's a score. Oh yeah, right. We're going to set these things to 0 first. So these are just always 0 initially anyway. So we don't need to, yeah, okay. I think the score should start off at 1, actually. That's the, yeah, you always start off with 1. And this is so we move, we have 8 food, current food not equal to end food, food, current food, food R, food C, right, get that out of the vector. We can, I mean, I was thinking we could dump all of the vectors for the food into pairs, a vector of pairs, but it's not really, there's no real reason to do that. So now what you can do is right, if we ate the food, then we're going to modify our food pointer, right? And set that, and also upgrade increment our score. And remember that we ate the food when we check whether or not our head is going to hit the bot, or when we actually move the snake. So check for eaten food if it's not equal to this. Okay, so we do that and increment the score. Whether snake hits the body, or yeah, update the snake body by removing the tail. Note, tail is not removed if the snake ate food. So if not ate food, we're going to remove the tail by popping from the queue. So snake dot push pop front back. Now my question is, when we from the queue we push, where does the queue get pushed to? The front and the back. I want to say the front is what we want. The front is, and it's a pair of things. Yeah. So we have auto, const auto, tail row, tail column is snake front, snake.pop. I believe that's what we want. And so that's if we didn't eat the food. And we're going to remove the tail from the set, which is snake body. Snake underscore body dot. Interesting. erase, or, well, we can do, we don't even need to do that, actually. Snake body is not always non. Yeah, we don't have to do any checks. We can just immediately snake front erase and snake dot pop. And then, so if we didn't eat the food, we do that. Otherwise, we do eat the food, and that's that. And we say check head against the body if next row if snake body dot count of standard make pair of next row next column, then turn -1. Oh yeah, have a boolean here too. Boolean game over is false. Our game lost, we'll say. There's that too. Like if you keep trying to play after you've already lost the game, the score should always just be the. Okay. So, yeah. So you lose the game, turn -1. If you haven't eaten the food, you remove it from the body, pop the queue, the tail from the queue, check the head against the body, right? If we hit, then we lost, and that's the end of it. Otherwise, now here we assume we haven't hit the body. We would update the position for the head, insert the head into the queue and the body mat. So we'll say snake body dot insert okay. Insert the head position and the snake dot push head position. So now we have this pushed into our queue and into our hash set. And now, what else do we want? And we'll return the score, which really the score could just be the size of the queue, size of the snake. Yeah. You can maintain the score this way too, that works as well. So, what happens if we do this? Let's compile. Compiles. So output 1, 1, -1, -1, -1, -1. Okay. Interesting. The score starts off at 0. Okay. Okay, score starts off at 0. I take that back. All right. So it's We actually don't need a score. We can do, I don't really need that. We can do can derive that from snake.size minus 1. Oh. Oh, I see. And the snake initially, snake.push initial head is going to be, you can actually just do 0. You don't need to use make pair, I think. I don't think that's necessary. If I recall correctly, it's not really necessary. So the initial head, put the initial head into the snake and the snake body, insert the initial head as well. Alright, what does that look like? So 0, 0, and then 0, 0, oh. What is this? 3, 2, 1, 2, 0, 1. Number of rows, number of columns. This is where the food is. 0, 1, 2. 0, 0, 1, 2. So 1, 2 is the initial. So right, down, right. We This is confusing. It's for the snake. I guess the snake back is what we should be using. I don't know. So we get the first two are fine. 0, 0, and then we should have a 1. And what happened? Do we enter this spot here? Something's missing here. No, we never into that spot, huh? Let's just see if we get into check 1. Okay. Check 1, check 1. 1, 2, 3. All negative ones after that. Now, I guess I want to know what this snake front is. That's one thing. I don't actually know what that's going to be. Although I don't think this even matters because I don't think we ever even eat the food, right? I don't know. It's confusing. So snake front 0, 0, 0, 1, 1, 0. Like, I don't know. This is fine until you get to the food. Then once you get the food, and then you might run into some trouble. What, we never actually hit this part though, where we hit the food, so something's going wrong. What is next row, next column? It's taking a while, man. It's taking a lot longer than it needs to. I think I could have done this a lot more efficiently. So next 0, 1, which is correct, right? Next column. And then check 1, we hit that, okay. And we don't hit check 2. Then next is 1, 0, we go down, which is not correct. No. Okay, so down is not correct. Down should be 1, 1, really. Why don't we get 1, 1? Oh, I know why. Oh, of course. Completely forgot. Duh. Seems really obvious, but somehow I missed that. I was so concerned with all the other pieces. I was so excited, I guess, about all the other pieces, and concerned and excited and interested in all the other pieces. But I totally missed just moving the snake in the first place. The head of where the position of the snake, the head of the snake. No kidding. So this one's correct. Okay. Can we do some other tests, maybe? Hopefully. I think I get this feeling something like this, you'd have a lot of different possible tests that you could go through. It's also been a while. It was an hour and a half we were on this. Yeah, we spent quite a bit of time on this. I would like to do this one again, I guess. Something like that. Let's do like 4 by 4 or 5, 4 by 5, and let's put a whole bunch of pieces of food in there. I don't know. I think the tests are going to be like kind of awkward. The things you really want to test are the 4 different boundaries, picking up the food and then circling back on itself, and then picking up the food and then running off a boundary, something like that. Those are kind of the things you want to test. So we'll do that. So we'll do a 4 by 5, and we'll do each boundary, I guess, and the food. We'll just kind of throw food all over the place. Random spots should be fine. 3, 0, 5. Oh, there's no 5. 3 by 4. 1 by 4. Right, something like that. And then you can just do 1, 2, 3, 4, 5, 6. We would want to do 1, 2, 3, 4, 5, 6. Yeah, that's fine. We're just going to go to the right 6 times. It really is just like laziness when it comes to me and these tests. Like, I just don't like to do write all these tests. I don't think it's good though. I think I should be CI from 0 to 3 only. The width. Oh, the height is the rows and the columns. The width is the number of columns. The height is the number of rows. That's super confusing. So, yeah. This is row column form and this is column row form. basically swap these numbers. So instead of 3, this actually can go to 4, and this can go 4, 3, and this can go 4, 1. That's confusing. That's confusing. But yeah, we have these 2 test cases now. So that's good. So we go all the way to the right, we can go all the way to the left, we can go down, we can go whatever. Go up 6 times. Actually, going up even once is enough. But we want to go down a few times. We want to go, we have right, up, down, left. Test all of these in one shot. These should all, oh no. What happened? Oh no! That's my mistake. That's okay. Not a big deal. Okay. A few different, oh really, what? Come on, what's the problem now? I didn't modify this one though. I got all the other ones, but I didn't get this one. It's kind of funny. Okay, try again. So, okay, that's sort of what we expect. And now we want to do a test where we go in unto ourselves, right? The Ouroboros test here. We can actually just get rid of these. We don't need these. Well, actually, you know what we'll do? We'll hold on to them just while we're working on it. So this one now, we want to say, what we want to do is move, we want to pick up enough food. So we got to get to size, so size 4. So 3 pieces of food will end up at size 4. We want 4 pieces of food. So we got 1, 2, 3, 4 pieces of food. And we're going to go, right, this is the, we got to go to the right. We got to go down. And we got to go to the right again. That gives us that piece of food. Actually, once we go to the right the first time, we'll pick up this food. We go down and to the right again. And now we want to go, I guess we'll go right one more time to get this guy. And then now we're, oh, but we're only at 1, 3. We still have to go down 2, 3 more times. So down 3 more times. Right, down, right, right, down, 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 down. Let's see what we get so far. Should end with a score of 3, I think, at this with this one. No, oh no, our score is only 1s, a bunch of 1s. Uh-oh. What are these row column, these things? These are, yeah. Right, so, okay. Number of rows, number of columns. Row, column. No, it's actually the other way around. It's reversed. This is with height, right? Height is rows, width is columns, so this being reversed is pretty awkward. But anyway, so the first move to the right should actually pick up the food, no? Or is this is row column? That's really surprising. Row 0, column 1, go to the right. We should pick up this piece of food here immediately. Right, like that's super confusing. And it says it's correct, whatever I'm doing. So we're not wrong, but what if we go up first? We can't go up first. We can go, what if we go down? Right, what does that do? We don't pick up that food. How do we pick this one up? Oh, it's because I'm sorry. I know. No, I know what the problem is. That's my mistake. I know what the problem is. The food only appears one at a time, so it's not all just kind of sitting there. I completely forgot. You gotta pick it up in order. That's my mistake. So that means you gotta go, okay, that was confusing. So right, down, right. So right, down, right puts us here. And then we'll just get rid of this one. That's a little confusing. So right, down, right gives us here. Now we gotta go back up. Right, down, right, up. And to the left takes us back to 1. Then we want to go to left again and start going down 4 times. How many times do I want to go down? 1, 2, 3 times? 4 times, really. 1, 2, 3, 4. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is 1, 2, 3, 4, 5, 6, 7. We need to go up to 11. 8, 9, 10, 11. All right, this is interesting. This is interesting. So 1, 2, 3. Now once we got the third value, we got to pick up this one now too. We got to go to the right 3 times now. So I'll allocate that space. 1, 2, 3, and this is going to be. These all really should have spaces between them. 1, 2, 3. We're just going to keep it consistent. Move it to the right 3 times. All right, how do we do so far here? All right, let's take a look. How do we do so far? Wrong answer. No. What do you mean we got the wrong answer? Output -1, 3, 3, 4. What is this? What is this? So once you lose the game, the game is over, turn -1. So actually they don't care. Their answer is wrong. Look at this, you see that? They keep returning the score even though the game's over. Uh-oh. Works on their test cases, but technically this is an error on their end. But anyway, so interesting. if you kept moving after the game was over, you would instead of returning ones, negative ones, you'd return the score. Which is definitely not correct. So anyway, I guess we ended the game somehow. When we got to 1, 2, 3, the three right positions. I think we went down one more time when we weren't supposed to go down one more time. We got 1, 2, 0, 1, 4, 0. Okay, so we got to 1, 2, 3. Made 2 moves, got to 1, 2. We gotta make another 2 moves, get to 2, so we're back to 0, 1. Then we made 1 move to the left to go to 0, 0. We made 2 moves to the left. No, yeah, 1 move to the left to go to 0, 0. Then we had to make 1, 2, 3, 4 moves down. 1, 2, 3, 4 moves down. The 5th move down was no good though. We have 1 extra move down. I don't know why that happened. Going to assume that their test cases will not continue past losing the game. And so it won't matter that I keep printing negative ones afterwards. Okay. Which is really, actually, that's really weird that they. Anyway. So okay, so now we're at 4. Okay, now we can run our snake back into itself. So now we're at this position here. 4, 3, and in order to run my snake, no, we're still a size 4, so we actually still can't run into ourselves. So we're going to try to run into ourselves, and then we're going to keep these test cases separately. So this one we're going to try to run into ourselves and not hit ourselves, and then we're going to do one more where we get the last bite, and then we do run into ourselves. So this is going to be interesting. So how do we try to run into ourselves? So we want to run into, basically make a circle, right? We're going to go up, left, down, right. So I think we're at 4, 3. We're in the 4th column. Yeah, we're like towards the bottom. And yeah, up, left, down, right should be fine. So we'll add 4 moves, right? 1, 2, 3, 4. And we're gonna add one, 2, 3, 4. It'll be up, left, down, right, up, left, down, right. See what happens here. Oh, we ended the game there. How? It's so confusing. It's 5-4. So we have 4 rows and 3 columns. Okay, so having 4 rows and 3 columns, that actually means that we have to be careful being here. Also, can you go up? Can you go in the direction that you came from? I don't think so, right? That's another question. The guarantee that the moves won't basically move backwards. That's another kind of subtle thing here. So this says 4, 3 means you're at row 4. It's 5 rows. So we're at the very bottom, the bottom right, column 3. 0, 1, 2. 0, 1, 2, 3 rather, yeah. We're all the way at the bottom right. So up, left, down, right. Huh? What? I'm so confused. And it's correct too. That's the thing that's so confusing. It's like I got it right, but it's just not how. What do you mean? Up and left, but somehow going down collides with something? Up, left, down, right. It's a 5-4, means it's got 4 rows and 3 columns. Or no, yeah, four rows and 3 columns. And this is this in bounds? How is that even possible? It's got 4 rows and 3 columns. Or no, 5 rows and 3 columns. I'm sorry. It's got 5 rows and 4 columns. This is the very bottom right. It's the 5th row and the 4th column. Somehow we go up, left, down. Am I crazy, man? Am I going nuts? Maybe we'll just add another move. We'll do 2 ups and 2 lefts. Because this is just confusing. I don't know where we are. I don't know. Add another up and another left. Come to find that we're all on the light left side now or something. Like, how did we end up over there? 1, 2, 3, 4. I don't know. I don't know, man. How did this happen? I don't know, man. I don't know. Okay, we're not expecting to end the game here. Not at all. Up, left, down, right. What? What? Why? What do you mean? Oh, you know what I think I did? I think I ate the last. Oh, that must have been it. I must have. No, I didn't. No, I didn't eat the last one. What is going on? How is this possible? We have 2 ups and 2 lefts, and somehow a down and a right knocks us out? That's not even possible. There's no way. There's no way. What is happening, man? I'm so lost. Okay, what is going on? Okay. Let me just save all this. How did I program this correctly? Yet when I try to run through the actual test case, it just doesn't make any sense to me. It's still programmed correctly, but it doesn't make any sense. That That don't make no sense. That don't make no sense. I don't trust it, man. If I don't know what's going on, how do you trust it? You know, how can you trust that? All right. So here's the sequences of moves and the positions. So we have right, down, gives us 1, 1. Actually, you know what we do? Make this easier. And the one more of these, the direction, we'll say. All right, how do we get, what does this look like here? Okay, right, down, right, up, back to 02, left to 01, left to 0, 0, down, 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 down to 4, 0, right to 4, 1. Right, that picks up the next, no. Oh, no, we don't pick up the food yet. No, we're fine. Right to 4, 3, up to 3, 3, left to 2, 2, up to 2, 2, left to 2, 1, down to 3, 1, right to 3, 2. And we never go 4, 1. We never hit 4, 1. You know? So we don't eat the food again. But somehow this 3, 2 ends the game? And correctly ends the game. Like the game is over correctly there. What? Can we move one more right position here? What happens if we move? When is the game? How is the game supposed to end? Like, how does that? I am so confused. Is it always supposed to have a -1 at the end? No, it doesn't always have a -1. Ha. Oh, my brain is just like turning to mush right now. I can't do it. How is it possible to say that a snake of length 4 cannot run into itself? Oh, because it did run into itself. That's the whole point. Because it's 1, 2, 3, 4. Once you've eaten 4 of these, it's of length 5, so it can run into itself. Okay, I get it now. All right, I was so confused. All right, so this is actually the case that we wanted to run into ourselves before. We did that already. Now I have to modify this so we don't run into ourselves. Gotcha. Duh. Oh man, I feel really dumb now. Also, approaching the 2-hour mark on this one. Nice. So let's go ahead and modify this. All right, that would be. Oops. Would explain some things. That would explain some things. Let's modify this so that way we, excuse me, run into. We only take 3. So we get to 4, 0, and then go to 4, 3. And now we do. So there's 4 Ds in this sequence. That's where we want to be. So 1, 2, 3, 4. From here, we want to go right, up, left, and down. And then remove 1, 2, 3, 4, 5 of these. So 1, 2, 3, 4, 5. These guys. See if that works. Alright, and that's what we expect. And it should not run into itself now. Okay. Got it. Alright. Yeah, that's always good. You know, oh, it's too funny. Oh, Will, bud. I spent so much time. Alright, let's see how we do. Hey, we got there. Woo! all that testing, all that time. Okay, so overall, pretty simple, pretty straightforward. We, this is brutal. This is rough. So we learned some things, I guess. First things first, implementing the logic for snake is actually really pretty easy overall. It's not too bad. You can use a queue and a set, an ordered set, and then some pairs. Manage everything with regard to pairs. Use an iterator and direction set, and you can set up a pair hash, write a struct for your pair hash for pairs. So you can use a set of pairs, and to keep it really simple, just use the int hash XOR to int hash, and right, it takes a pair to create the hash, right? So that's pretty neat. Thinking, what do we want to do here? Yeah, you can map right directions, strings to directions. Have a snake body, number of rows, number of columns, determine whether the game has been lost, an inbounds check, update their directions to get the next row, next column. If it's out of bounds, you lost the game. Do a food check. If you check out the food, ate the food or not. If you did eat the food. So the way it works, the body with the snake body is that if you did eat the food, then you're not going to remove the tail. But if you didn't eat the food, then you remove the tail, and you remove it from the set that represents the snake, and you pop it from the queue in order to know. The queue allows you to figure out which row column pair you want to remove, and then you have to check if the head is, after you remove the tail, if you remove it, check if the head is now hits the body or at all. And obviously if you ate food, it shouldn't. Although the food technically could appear, now here's the tricky thing, the food could appear on the body, in which case it doesn't really matter, because if you eat the food, it can only make this check harder. So this is fine to do the food check here. And it's actually a good question. If the food, now you get something funky here. If the food is where your tail is, so in other words, if the food shows up where your tail is, and you jump on it, you're going to run into your tail. Which actually is correct here. If there's no food there, it's no problem jumping on your tail. But if there is food where your tail is, you actually lose. Which actually, I've lost games playing Snake, randomly chasing my tail when the food randomly pops up around the map. And I've wondered why. It's happened to me before when I was a kid. I played Snake a bunch because I was trying to, play it, get good at it, I guess. And there was a game mode where the food would kind of randomly pop up. And I think the food randomly popped up on my tail once because I was moving and I just suddenly died. And I was like, what's going on? Right? It's because the food could actually pop up if it's not programmed correctly, or if it's programmed in such a way, it could pop up on the body of the snake, specifically the tail, and then you can actually jump onto it, thinking your tail is going to disappear, but your tail doesn't disappear because the food is there. It's a tricky thing, huh? That's a tricky thing. Food, you can program so it's in such a way, the logic in such a way so that the food, doesn't. You can program in such a way such that the food doesn't pop up yet until the snake has moved out of the way, until it's moved away from the. So it's moved away from the food. Pretty interesting. And you have to remember to update the snake's position. You got to insert the head of the snake into the queue in the body map, or the body set. Yeah, with the body and the set representing the body. Yeah, there's all these little, or there are all these pieces. 1, 2, 3, or 1, 2, 3, 4, 5, 6, 7. There's like 8 different pieces to this. It's kind of a lot, you know. It's not hard, I think, but it's definitely involved. Yeah, I guess it's pretty reasonable that it took 2 hours or so. There's a lot of just pieces going on here, a lot of concepts, different parts. I'll submit one more time, see how we do. But that's not too bad. We did okay. I think we did good. I think we did all right. Apparently, there's a way to be even more efficient than this, which I don't know. I don't know what I did. What I could have done differently to be more efficient. Maybe this map for the directions could be faster somehow. I don't really know. I don't know. Character map instead of string map. I don't really know. Maybe the manipulation that I'm doing with the pairs could be different also. These manipulations, because there is a bit of like creating pairs and removing pairs. Yeah, manipulating pairs. Doesn't seem that bad though. There might be a slightly more efficient way to do it. You can maybe have like 2 queues of integers or something instead of a pair of integers in a queue. And then, because manipulating integers is slightly more efficient than manipulating pairs. And then you would just do like the check wouldn't be, you'd only have a hash of, you have 2 maps as well. And so the hash function is a little more efficient than this one, I suppose, something like that. And no, you kind of need, one way you could do this to make things more efficient is to interpret everything as a single array instead of interpreting things using pairs. And so you have a row column, and there's sort of a function you can go from row column to the one-dimensional array, and then from the one-dimensional array back to the two-dimensional array. You could do it that way too. That might be slightly more efficient. That may be how it was done. That it was more efficient. Although, yeah, this is good enough, I think. All right, so let me go. Thank you for watching. I appreciate it. I will talk to you soon. And yeah, I hope that was interesting. That was definitely a learning experience for me. I've tinkered with other stuff similar, like other game-related things, like Snake and Tic-Tac-Toe, and what's the other one? There's another one, Minesweeper. These kinds of games are. I'm just also noticing like the gain. It's pretty high. It's actually really high. So yeah, so I noticed. Yeah, I noticed that I've worked on other similar kinds of questions, similar kinds of game type questions, and tinkered, and yeah, it's interesting. It's kind of involved. I think in this case, the most interesting part would be. I think one of the harder parts or more interesting parts with regard to these kinds of things, these kinds of questions, these kinds of games, really is like the graphics portions. That matters a lot. It's what it is. It's not that part's super interesting. It's just that part is, I guess, the part I'm least familiar with, the least knowledgeable of. Like, I don't know how I would even begin. I mean, I've seen like JavaScript examples of games on sort of on like websites where you have like Snake implemented in JavaScript. You can play it in the browser. However, there's definitely a lot of like other stuff I'm just not aware of or don't know how to do, so something like that. And anyway, yeah. So this is interesting. So yeah, thank you for watching. I will talk to you soon. Have a good rest of your day. I think I'm gonna take a break for a bit, come back to another problem. Yeah, this is like 2 hours I spent on this. I mean, this is good. You know, we learned some things. Got a little more familiar with like different things you can do in C++ to kind of work with a problem like this. So got a little practice too. If I saw a problem like this, I think in an interview, I think it'd be pretty challenging though to get it right on the spot. It's definitely pretty involved, this one. So yeah, take care.